Hello everyone, welcome to my chemistry channel BLDASH short and sweet in chemistry. Now this is the chapter, the short revision of electrochemistry, that is part 7. In part 7, I want to explain measurement of electrode potential with reference to standard hydrogen electrode. Then what is standard hydrogen electron? And this chapter is very important for class 12th. Now standard hydrogen electrode, that means it is a primary standard electrode, that is very important, from which we can calculate all types of electrode potential. It consists of a small platinum electrode. You remember in S.H.E., that means standard hydrogen electrode, platinum electrode is coated with platinum black. H to absorb hydrogen gas, because hydrogen gas is formed, that should be absorbed. A platinum wire is welded. How to prepare that platinum electrode? That a platinum wire is welded to the platinum strip and sealed in a glass tube. The electrode is dipped in acidic solution. How to prepare S.H.E., standard hydrogen electrode? That electrode is dipped in a acidic solution H+. That means hydrochloric acid having strength 1 m. What is the molarity? 1 m. Then here the concentration of the hydrochloric acid is 1 m, and the concentration of both reduced and oxidized form hydrogen is unity. That means if in oxidation form you can see or reduced form you can see, that value should be unity 1 m. The pressure of hydrogen gas 1 bar. When you see what is the pressure of hydrogen gas, that is 1 bar. Pure hydrogen gas, that means you should take pure hydrogen gas and pressure is 1 bar, is bubble in solution. In solution means what solution? 1 m HCl, and temperature is 298 Kelvin. The surface of the foil acts as site for the reaction. The surface of the foil, the surface area, is the site for the reaction. Now point is S.H.E. is half shell. How can you calculate that it is half shell? Now what is the that is representation of this half shell? Pt means platinum, solid, and hydrogen gas, that is 1 bar, and here, and that is dipped in H+ aqueous, that is 1 m strength. Now it acts as anode. Sometimes when necessary it acts as anode, and sometimes when necessary it acts as cathode. That means standard hydrogen electrode act as a cathode and anode both, depending on the chemical reaction. And if S.H.E. act as a cathode, then what happens? It addition of electron takes place. So addition of electron takes place, that is hydrogen gas is formed. 2H+ gives hydrogen gas. Clear? If it acts as anode, then what to do? It release electron, then it gives 2H+ plus 2 electron. Here 2 electron is added, here 2 electron is subtracted, that means release. So S.H.E. act as a reversible electrode, that means H2 gas, it gives 2H plus 2E minus, where electrode potential you can see that is 0. Now this is the diagram where you can see hydrogen gas is passed here, and this is a platinum wire, I told, in platinum black on the lower side, and 1 m HCl there, and bubbles, hydrogen gas is bubbled. Platinum black, very important, this is platinum black, and it is platinum wire that is welded. Measurement of electrode potential, this is called S.H.E. standard hydrogen electrode. I told it acts as a cathode and also acts as a anode where it is necessary as it like. as required. Measurement of electrode potential. Suppose we want to measurement of electrode potential of any, then S.H.E. can be used as required as cathode or anode. It can be done connecting with S.H.E. Then it should be connected, that electrode potential of any cell that should be connected with S.H.E. The electrode potential electrode is determined with respect to S.H.E. I told S.H.E. act as a cathode, S.H.E. act as an anode when it is required. Then here also, if any electrode you want to calculate the electrode potential, they should use that S.H.U. as a standard here, electrode potential represented by E0 or E to the power this one. This is called electrode potential, standard electrode potential. And then what happened to measure the standard electrode potential of metal, any metal, zinc, copper, like this, and here 1 m solution of electrolyte is taken in a beaker. Suppose I want to take a copper, then copper solution that having strength 1 m is taken, just like copper sulfate, that means copper sulfate. Here electrolyte taken in a beaker and a metal electrode is dipped in. Metal electrode copper is dipped in copper sulfate, or zinc is dipped in zinc sulfate solution. It is the metal ion electrode, that is M dipped in M plus N, that means it acts as a metal ion electrode. The half cell is connected to S.H.E. That means this is the half cell. This one is a half cell and S.H. is a half cell. Both are connected by salt bridge. The electrodes are connected to voltmeter because you should know what amount of current is produced, what is the that value is counted as electrode potential. From the measured EMF of this cell, you can see what happened here. The half cell, you can calculate standard electrode potential of the half cell. So, measurement of electrode potential Zn plus oblique Zn. That means here Zn is dipped in zinc sulfate solution. A zinc rod dipped in 1 m zinc sulfate solution, it is called half cell. It is known as half cell and combined with standard hydrogen electrode, that is S.H.E. This is S.H.E. and here through salt bridge. Salt bridge should be required. Both the electrodes are connected through the voltmeter, where you can calculate what is the potential developed. And then we can see the deflection. When the current is produced, then deflection in the voltmeter indicates current is flowing. From what? From hydrogen electrode to metal electrode. Hydrogen means, that is S.H.E. to metal electrode, that is here zinc. So, or you can say electrons moving from zinc to S.H.E. Zinc to S.H.E. Zinc electrode acts as anode and S.H.E. electrode as a cathode. So, here this is the formula: E cell standard and E standard cathode and E anode. So, E cathode should be higher value than E anode value. That is why E cell should be positive. Then reaction, what is the reaction when zinc is dipped in zinc sulfate and here S.H.E. is the other half cell? Then here this is the reaction: Zn losing electron and 2H plus gaining electron, and this is Zn plus 2 aqueous and H2 gas. So E0 cell, that is here, this is called cathode, this is called anode, and the E cell value that is given by the voltmeter, that is 0.76 voltage, and E S.H.E. that what is the value? 0. So 0 minus this value. So you will get zinc electrode value, that is minus 0.76. representation of this cell, how can you represent this one? Because this is the Zn plus 2 oblique, that is your salt bridge representation. It gives 2H plus aqueous 1m strength where hydrogen gas with 1 bar atmospheric pressure. Measurement similarly, how can you calculate that electrode potential of Cu copper electrode, that is Cu plus 2 oblique Cu. Copper rod is dipped in same in zinc rod. Here copper rod is dipped in 1m solution of copper sulfate. It is combined with it is connected with that S.H.E. through a salt bridge. Everywhere without salt bridge, the connection never be completed. Both the electrodes are joined through a voltmeter. Why you are using voltmeter? Because you should know what current is produced from the deflection in voltmeter. There you can see current is flowing from copper electrode towards S.H.E. and here current flowing from copper electrode to S.H.E. and electrons flowing just opposite direction. So electrodes are moving from S.H.E. to copper electrode. The hydrogen electrode S.H.E. acts as anode and copper electrode acts as cathode. So this is the anode S.H.E. and copper is as cathode. E cell equal to E0 cell, that from that complete reaction E cathode minus E anode. And the reaction is, here you can see copper plus 2 gain electron and that side here copper lose electron. And so E cell equal to that is cathode minus anode. Here copper plus 2 oblique copper is act as cathode. So E0 cell equal, that is obtained from the voltmeter deflection, that is 0.34 voltage by the voltmeter. So cell representation, how can you write the cell representation? That is here anode, this is cathode. So how to calculate EMF of this cell? That is copper, that means electrode potential, that is of copper minus E, that is S.H.E. This is S.H.E. and this side cathode minus anode. So here you know now it acts as anode where the value is 0, and copper plus 2 value that is for the whole cell, that is the 0.34 voltage. This sign is, you can write also plus. So this is the value. Then here how can you calculate electrode potential of copper? That is 0.34 voltage. This is the value of copper electrode by using standard hydrogen electrode. Now see the diagram. Here when zinc electrode acts as an anode and S.H.E. as a cathode. This is the S.H.E. This diagram already I explained, and this is the salt bridge, and this is the zinc in zinc sulfate. That means zinc in zinc sulfate, that is at anode, and here S.H.E. now required as cathode. So this is the calculation of the per electrode potential of zinc electrode. When here you can see copper electrodes acts as cathode and hydrogen electrodes act as anode. Before that hydrogen electrode act as cathode, but here it is just hydrogen electrode as anode. This is anode and this is cathode. Then reaction in Daniell cell. Then what are the reaction? Here half cell reaction of zinc electrode and copper electrode, and left electrode, that is here left side, left electrode is zinc, and here the right electrode, that is copper. So what is the reaction? Right electrode Cu plus 2 electron gives Cus, and left side electron of zinc loses 2 electron, give Zn plus 2. Overall reaction when right electron, left electron both are combined, then what is the overall reaction? This is the overall reaction. Zinc, see, zinc loses electron, copper gains electron, a Zn plus 2, right side. So it is the production of zinc losing electron, and here the production of gaining electron. So what is the EMF of this cell? EMF of this cell, E0 cell, that is standard EMF of the cell, right, E right minus E left. E right means here cathode, and this is anode. Cathode value, this is 0.34 voltage, whereas anode value minus 0.76, or you can say plus 0.34 voltage, this one, and this is minus 0.76 voltage. When you take the result, the EMF of the cell, it is the addition, so it gives 1.10 voltage. Sometimes metals like other metals like platinum, gold uses inert electrode. They don't participate in the reaction but provide their surface for the reaction. See, this is the inert electrode, means they provide the surface but never participate in the reaction. I hope it is clear to you how can you calculate electrode potential of different metals. And myself, B.L.D.ASH, ex-PGT Chemistry, Kendra Vidyalaya Sangathan.